This is for Year 12 Specialists. It comes out of 9H using Euler's method to solve a differential equation. And it's number 7, so it's an approximation of the normal distribution. Okay, so we actually haven't come across the normal distribution in any of our work yet. We will in methods and we also will in specialist. But the standard normal distribution is the bell-shaped curve that we have heard about. Normally, populations and distributions follow a bell-shaped curve. Okay, this is the rule, which is the normal distribution. And I've got it over here for you. So I've typed it into my class pad and I drag and drop, and you'll see that it fits the bell-shaped curve. And what this is saying is that Z is the variable's name for the distribution, and we're saying that Z is less than or equal to small z. So I'm going to say that small z is there. So that the area is the integral from negative infinity to z of f of x, where this is f of x. So what we're saying is that the probability is the area under the curve from negative infinity all the way through to z. Since it's perfectly distributed, then I know that this half is exactly that, half. So that's a half. So it's the same as a half plus the integral from 0 to z. So I'm saying that I have two bits to it. I have the blue bit, which is a half, and the yellow bit, which is this bit here. And we're going to use this in the normal approximation. So I'm going to say that y equals a half when z equals 0. So z of 0 is going to equal a half. And we're saying that the dy dx or dy dz will be this particular expression, because the integral of that expression gives me the answer that I'm interested in. So I'm going to use Euler's approximation method, where my change in x is going to be 0.1. That my y is going to start at a half, and y dash is going to equal this. So I'm going to go over and have a little look in menu, e-activities. Euler's formula is opened up. Euler's iterations. F of x has to equal. And I need 1 divided by bracket. Bring up keyboard, square root 2 pi, close bracket on the square root, close bracket on the division, e to the power of negative x squared divided by 2, close bracket on the e, open bracket, close bracket, open two brackets, close two brackets. Okay, when I press XE, that should be fine. X start from 0, goes up by 0.1, y starts at 0.5. And execute, and if I go down, when x is 1, y should equal, and I look all the way down here, and that's where I can see where that number is. Okay, so that's Euler's approximation. Use the CAS calculator. Again, you don't know how to do this, but I'll show you. So if I go to menu, main, interactive, distribution, continuous, normal CDF, lower is negative infinity, upper is 1, okay, and that's what CAS gives me. 0.84134447461, and that's what Euler's approximation. The first two decimal places are the same, a little bit of an overestimate on the third decimal place. Okay, so how do I do this? I need to do an approximation for 1 and 0.5 using 0.01 as my step up. So So if I go back to menu and I go back to activities and I go into the first one, it's still there, thank goodness. Now I need to add a lot more rows. In November you're never going to be asked to do a lot more rows. However, I will, and the reason I don't really want to do it is that I'm going to use up lots and lots of my battery because it's going to take forever to calculate 100 calculations. So I've gone 0.01 and I'm starting with everything else is the same, and if I go down that will only take me 2.5. So I touch two cells, I go up to edit, file, edit, I'm looking for fill range. I've gone to 57, I need to go to 107. Okay, now if I go all the way down that should take me to 1, it did. So I need to fill down the other two columns as well. If I pick two columns, edit, fill range to 107. I just added another 50 because I knew I got down to 50. And select two cells, edit, fill range, I wish to go to 107. And OK. Now that I've done all of that, when I get to 1, that's what the estimate for this is. From 0 to 1, I'm using steps of 0.01, so 0.8421, looking down the bottom, 8421275, which is a much closer estimate. That's 1 and I was at 2. This is correct to CAS, whereas these are estimates using Euler's approximation. And if I'm looking for 0.5, then I would go up to 0.5. So that estimate is 0.6916 9537. And to double check that against CAS, if I come to main and I make that 0.5, and then recalculate it, that's the actual answer, 0.69146, and that was 0.69169. That's number 7.